Hello, I'm Ehsan. In this video, I want to talk about a module. It's called DF Player Mini. I write a library code and I want to show how use it and how the circuit is function. Okay, at first go to Datasheet DF Player Mini. I want to show important thinking module. Brief instruction, it's explain about what's the protocol supported or other thing you can read it. And after that we have future support MP3 and WMV decoding. The rate of sampling is 8 kilohertz, 11.055 kilohertz, and the other so on. And the support FAT16 or FAT32 file system maximum support 32 gigabyte TF card, and built-in 3-watt amplifier and 30 level volume is adjust, 10 level EQ adjustable. After that, application, car navigation, voice, broadcast, road transfer, inspector, toll station, voice prompts, railway station bus, safety inspection, voice prompt, electricity communication, financial business hall, voice prompt, the public security, border control channel, voice prompts, on the other so on. The main thing in here, module application, instruction, mp3 format, see that, UART, TTL level baud rate adjustable, default is 9600, standby current 20 milliampere, and operation temperature and humidity. This part is important. We have 16 pin to output, VCC connected to power supply. RxTX is connected to UART, but it's reverse. Actually, you know that Rx connect to TX port and TX port connected to Rx in micro. DAC R and DAC L, especially for headphone and speaker 1 and speaker 2 output. For speaker, we have two ground in here, and busy mode USB port, add key 1, add key 2, and IO1 and IO2. It refer to we work on manual. Then yes, explain about port. Serial communication protocol. Serial port as a common communication in the industrial control field. We can conduct an industrial level of optimization, adding frame, checksum, or error handling or other so on. The baud rate is 9600. This is really important. The format is start byte. After that, version, len, CMDs related to comment, feedback, para 1, para 2, checksum, and end bit. Para 1 is parameter 1, para 2 is parameter 2, and checksum. Let's explain about checksum a little. Checksum is that a protocol when we use the UART. When we use UART, we need to check a bit, and we have a protocol is called checksum. Checksum, it means we minus or plus or cross or divided uh, something for in my string, and when we get to the receive is check. When we have don't change, it means the string of my code is correct, and when we have change, it means we have problem and comment not run. This is really important. um, after that, yeah, start with always is 0 cross 7e, version is 0 cross ff, the len is 0 cross 06, command is can variable, feedback in my library always 0, parameter 1 variable, parameter 2 is variable, checksum I will explain in my code, and end byte is 0 cross ef. This is the table for command, next previews specifier tracking, and the other you can see pause, playback, reset module, and so on. And the next, what is the next? Important, I want to explain. As I say, 70 starts, FF version, 06 data length, 03 is common, 00 is feedback, 00 is power 1, 01 is power 2, FF is checksum, E6 is checksum. I show how the calculate checksum, and end bit always EF. This is the example of that. And finally, it's in figure 3.2 file name, we must use this style 001, 002 until 255, and we have the folder name. After that, yeah, this is the application circuit. In figure 4.1, it's referred to what happened in here, and figure 4.2, the other application for circuit, and the other referred diagram, it's for manual. Yeah, this is for manual. It's for key. Add key 1, add key 2, IO1 or IO2. And this is for manual. This is PCP type, and just that. Yeah. Okay, go through the my application circuit. Open it. This is my board, and I set 3 pin as inputs and pull down it in push button. This is for play or pause. It's connected to PC7, and this for increase, excuse me, decrease, decrease volume, and previous track. It's connected to PC6, and finally uh, increase volume and next track. It's connected to PC8, and this is the module, uh, VCC connected to 3.3 volt, ground connected to ground, and I use this because I don't have a speaker, uh, and I use it for DAC R and DAC L. For one cable is IUX in connected to a speaker, and this is my circuit. Okay, go to table command. I want to show what's happening in table command. Okay, uh, this is the table command for play, folder, next, previous, decrease, increase, repeat mode, and the other so on. As I say, start bit is always 0x7e, version is always 0xFF, and len is 0x06. The command is variable, the feedback is always 0x00, and the para 1 and para 2, it can be a variable, but in my library para 1 is always 0x00, and the para is variable. I explain that. For example, what's different between par 1 and par 2? When we have the function, for example, play folder, or pause. We need to specify is one play folder after we push button or two or three track after that. But in this part, we can specify with one, two. When we push the play, is one track after that is play. But when I use two, is two track play after current situation. For example, in EQ normal, EQ pop, EQ rock, EQ jazz, and EQ classic, and EQ bass, all command is 0x07. But what's different between of them? Okay, we use it parameter 2 to separate the command. For example, 0x00 is specified for normal, 01 is for pop, 02 for rock, 03 for jazz. Yeah, it's my choice to use that 0, 1, 2, 3, or 4. The main point is here, checksum high and checksum low. And I want to show calculated in my calculator. I search cal, okay, go to program and set as hex. For example, in play folder, I'll explain checksum in my code, but it's better to know 0 minus checksum transfer to checksum. This is this function for checksum, as I say. Okay, we write 0 minus FF for version, and then minus 6 for len, minus D for comment, and minus 1 for parameter 2. After that, we have FE for checksum high and ED for checksum low. Another example of that, for example, next. 0 minus FF for version, minus 6 for len, minus 1 for command, and minus 1 for parameter 2, and we have FE F9, checksum high and checksum low. This is my table for checksum high and checksum low, and really important to know about it. And just like that other example, you can calculate with calculator. And you finish. Go through the make it code. Click the STM32 mix. Wait a second. Okay, access to MCU selector. Choose your micro. For example, I use STM32 F103 RE. Okay, I use this. Double click in LPQ package. Okay, go to system core and set system on serial wire, and next 1, 2, 3 inputs, PC6 as input, PC7 as input, and PC8 as input. Okay, and go to connectivity. I use user 2, click here, open this, mode change to asynchronous. As you know, for UART is asynchronous mode. Go to parameter, change baud rate to 9600, and user contact is nothing, NVIC setting nothing, DMA settings nothing. Okay, everything's okay. And go to project manager, test one, use that file, okay. Use your compiler. I use K. Go to generate, copy all the necessary library, and generate code. Okay, open project, see that test one, go to application user and click here. We want to add this library to project. Okay, go to, I cut it to test one, core, and scr4.c and paste it. And the other one for .h header, I cut it and paste in here. Okay. Uh, Open the Kale. Right click in here, go to option add group, click here and change this name, for example, DF player. Okay. And add.c in library code. Okay. Click right here, go to add existing file to group, go to desktop, test one is the name of my project, go to core, go to src and add code. Okay, you can see that my code, and left click, after that right, go to header dot h. You can see my that h coding here. This is my library, and I want to explain that. I use send underline cmd for send command, and as I say, paramet1 and paramet2 and checksum is variable. Okay, at first version cmd cmd feedback para1 and para2 goes to checksum. After that, 0 minus checksum. Uh, as you remember, I use calculator and 0 minus ff, after that minus 6, after that minus comment, after that minus parameter 2 is here. And all the string in UART go to CMD sequence. A start byte version, CMD length, CMD feedback, para1, para2, checksum and checksum, and end byte is AF always. And transmit with a function transmit of UART. After that, I define check underline key for my push button, for pause or playing, and for decrease or increase volume, and next or previous track. Go to my library. You can change the number to is 1, 3, or 4 in yours. You can use, and you can change 6, 7, and 8 number to port you define as input, and you can change C to A, B, or C, or D port as input you define. And yeah, that's fine. I uh, uploaded this library to my OneDrive, and I put it link in description. If you want to download, you can send me message and I confirm that, and I allow to download this library and use it. Okay, go to option for target, debug, setting, flash download, always tick in here, reset and run. Okay, okay. And oh, Don't forget add the includes library to begin include. I use it notepad because I don't have enough time to rest. Copy this and add this part. This is my header. You must add it in your code and in the while. Uh, okay, to enter and use the check function key here. After that build, maybe just take a second. Uh, Wait until compile my code. Okay, zero error and zero warning, and upload it to my board, and I will show my board and three key I define as inputs. Okay, this is my circuit. I use three push button in here. For the middle of them is for pause and play, and this push button for decrease volume and previous track, and this push button is connected to PC8 for increase volume and next track. And this is my speaker. You can see. Uh, let's the speaker move to near microphone. My laptop. Okay, you can hear the voice as it clear. And at first we try pause or play. You can see this LED when the music play. This LED is on. You can see I push for pause or play. I'll smile, I know what it takes to fool us down. Play is pause, and then do it till the sun goes down and all through the night time. Okay, the middle push button for pause or play. Go to increase and decrease. When you press this push, these two push button, I mean here and here, and push it for 3 seconds. We have increase and decrease volume. Let's try it. Oh yeah, oh yeah, I'll tell you what you wanna hear. Get my sunglasses on while I the volume is decrease. The volume is increase. Okay, let's try to previous and next track. This, let's decrease volume. Okay, this key for next track and this key for previous track. This is the next track. This is the next track. Okay. This is previous track. Okay, thanks for watching my video. Please subscribe me and bye.